You know that feeling when you're trying to tune an old radio and all you can get is static? For ham radio operators, finding a tiny signal in all that noise is the whole game. But what if a computer could do the hard part for you?
Okay, so take a look at this. It's basically just a wall of sound, right? Pure static. But here's the crazy part. There's a secret message buried somewhere in there. The real question is, where would you even start to look for it?
All right, let's get into it. This right here, this is what you're up against. A weak radio signal that's just completely swamped by background noise. And this is a huge headache for guys like Hal Feinstein, an amateur radio enthusiast. He loves hunting for these distant signals, they call them beacons, on the 10-meter band. The tricky part is, they pop up for just a few seconds, and then poof, they're gone. Makes them almost impossible to pin down.
So, Hal figures, why not tackle this classic problem with a modern twist? He wanted to see if he could pull that signal out of the noise, but, and this is the key part, without any fancy, super expensive gear. Just using simple tools that, honestly, almost anyone could get their hands on.
And check out his toolkit. It's surprisingly simple. He's got an SDR play receiver, that's to actually grab the signal from the airwaves. But everything else, it's all software. We're talking Python, a super popular programming language, a Jupyter notebook to keep the code neat, and the real game changer, ChatGPT 4o, the AI. Okay, this is where it gets really cool, the strategy itself. Instead of, spending ages trying to become an expert in digital signal processing, Hal did something different. He used the AI as his personal coding buddy. He just described what he needed to do, and ChatGPT actually wrote the software for him. But it's not magic, right? Hal makes a really important point here, and it's a good warning for all of us. AI is an amazing tool, for sure, but it's not foolproof. It messes up sometimes. You still need a human, a real person, to double-check its work and steer the ship. So with the AI basically acting as his co-pilot, Hal put together this awesome three-part solution. He built his own custom digital toolkit, just one step at a time. And the process he came up with is just so logical. It makes perfect sense. Step 1, you have to see the signal that's hiding in all that noise. Step 2, find out exactly where it is. And step 3, just get rid of everything else. So let's break it down, starting with that first step. Program number 1 has a really simple job. It just takes that audio file, that wall of static from the beginning, and turns it into a picture, a graph, or what they call a spectrum. That way we can actually see all the different frequencies hiding in that sound. And this is the code that makes it happen. The cool part? Hal didn't write a single line of this from scratch. He just gave ChatGPT a simple instruction, something like, hey, write me a program that can read a .wav file and show me its audio spectrum. And boom, this is what it spit out. So he runs the code, and this is the result. This graph just perfectly shows how powerful that first step is. I mean, look at that. In the middle of all that fuzzy noise, there's this one huge can't-miss-it spike right around 2,000 hertz. So the signal wasn't gone, it was just buried. And now we can see it. Okay, so now we can see the signal. What's next? Well, we need its exact address. We need another program that can analyze that graph and tell us the precise frequency of that big spike. So you guessed it, Hal went right back to his AI assistant. He asked it to write a program that could find the strongest frequency in the file, and just like that, here's the code it generated. And get this, the code found it. The peak wasn't just near 2,000 hertz. It was exactly 2,000.77 hertz. That one number, that's the key to the whole thing. It unlocks the entire puzzle. All right, this brings us to the grand finale, the last and most powerful piece of the puzzle, an audio filter. The best way to think about this next program is like a pair of super precise digital scissors. Its only job is to snip away every single audio frequency except for a tiny little sliver right around our target, that 2,000.77 hertz. So Hal told ChatGPT to write a program that would take the original audio, run it through a special kind of filter, it's called a bandpass filter, and then save a brand new, cleaned up version of the audio. This code is what basically erases all that static, leaving behind just the one signal we're interested in. Okay, let's recap. We've seen the signal, we've found its exact address, and we've built a custom filter to isolate it. Now comes the big reveal, the aha moment. What does it actually look like once all that noise is gone? Wow. I mean, the difference is just stunning. On the left, that's the original audio. Total chaos, right? Just a fuzzy mess. And on the right, that's after filtering. It's clean, it's crisp, it's a perfectly clear pattern. All that noise has just vanished. So what is that pattern? Well, it's the unmistakable beat of Morse code. You can see it right there. Those clean peaks and valleys, those are the dits and das, the short and long beeps of the beacon's hidden message. And with that clean signal, the message could finally be decoded. That signal that was impossible to hear before, it was clearly transmitting the letters 9mm.
So let's just put a bow on this. The whole thing started with a wall of static you couldn't make heads or tails of. But using just 3 simple programs that the AI wrote for him, Hal turned that mess into crystal clear Morse code. And those letters he found, 9mm, well, they were part of a coordinate that helped him identify the beacon's location all the way near Mexico City.
But, the real story here isn't just about finding one lost signal. This whole project is so much bigger than that. It's proof that there's a totally new way for hobbyists, for tinkerers, for anyone really, to tackle these kinds of complicated problems. And Hal says it best himself. When you've got tools like AI that can act as your coding partner, suddenly those really complex projects don't seem so out of reach anymore. The barrier to entry has just been blown wide open. What you can build, what you can discover, it's really only limited by your own imagination. Which kind of leaves us with one final thought. With these incredibly powerful tools now so easy to get to, you don't have to be a programming genius to build your own custom solutions anymore. So that really begs the question, what problem are you going to solve next?